Welcome back. Lesson 01 was, let's be honest, a friendly lie. You learned 3 chains: input, output, forward, and that was enough to write your first rules. But the real iptables is bigger. 5 tables, 5 built-in chains, and a matrix that decides where a packet gets inspected and what you're allowed to do about it. Every command you've run so far quietly defaulted to the filter table. Today, we meet the other 4, and the -T flag that unlocks them. Here's the roadmap for the next 20 minutes. 4 ideas, in order. The -T flag is how you pick a table and silently defaults to filter. There are 5 built-in chains, not 3. Tables and chains form a matrix, sparse with empty cells, and once you see it, the confusion lifts. And finally, targets. Beyond accept and drop, you've got reject, log, and return waiting in your toolkit. Let's start with tables. There are 5 of them, but here's the secret. You'll live inside filter 90% of the time. That's where accept, drop, and reject happen, the bread and butter. NAT handles address translation when you're doing port forwarding or sharing an internet connection, and we'll dig into that in Lesson 7. Mangle, raw, and security exist for genuinely niche jobs: packet field tweaks, contract bypass, and Linux labels. Useful to recognize, rarely needed. Now for chains. Lesson 1 showed you 3. That was a friendly simplification. The full set is 5 hooks, firing at different moments in a packet's life. A packet destined for your box hits pre-routing, then input. A packet your box originates goes output, then post-routing. And anything just passing through, the router and Docker scenarios, runs the gauntlet of pre-routing, forward, post-routing. Once you know when each one fires, you know exactly where to drop your rule. Here's where tables and chains collide, and the punchline is that not every combination is legal. Filter skips pre-routing and post-routing entirely, which is why you never do NAT in the filter table. NAT avoids input and forward because it only cares about routing decisions. Mangle shows up everywhere, but you'll rarely need that reach. Raw and security? Niche corners you can safely ignore until you can't. If you memorize one thing today, make it this grid. So once a rule matches, what actually happens? That's the target, the verb at the end of every rule. 6 of them carry almost everything you'll ever write. Accept lets it through, drop silently swallows it, reject slams the door but at least sends an ICMP courtesy note. Then the non-terminals. Log writes to syslog and keeps going, return bails out of a custom chain back to the caller, and DNAT/SNAT rewrite addresses, but only in the NAT table, and that's a Lesson 07 problem. So let's put it all together with a real command you'll actually type. Read it left to right with your new vocabulary. -T NAT picks the table. We're rewriting, not filtering. -A pre-routing appends to the chain that fires before routing decisions, which is exactly when you want to redirect. And -J DNAT is the target that does the rewrite, sending traffic that arrived for port 80 over to 10.0.0.5.8080 instead. Table, chain, target. 3 questions, 1 rule. Now you might be wondering, why 5 tables at all? Why not just one big rule book? 3 reasons. First, separation of concerns. Filtering and address rewriting are genuinely different jobs, and mixing them would turn your rules into spaghetti. Second, ordering. NAT has to happen before routing. Filtering has to happen after. The table structure encodes that timing for you. And third, performance. Empty tables cost nothing. The kernel just skips them, so you pay only for the logic you actually use. And this is the slide you actually print out and tape next to your monitor. 3 columns, 1 grammar. Pick your table with -T, pick your chain based on where the packet is in its journey, and pick your target with -J to deliver the verdict. Filter is your default home base. Accept and drop are your bread and butter, and everything else on here is just vocabulary you'll grow into. Memorize the shape, not the cells. The cells you can always look up. Memorizing the matrix won't stick until your fingers type it, so here are 3 drills. Start with 2 reads. List every table to confirm the chain layout matches slide 5, then go decode a real Docker or distro rule and say out loud what it does. The middle one is your right, a log then accept pair on input, which also teaches you that log doesn't terminate. And please set that 2-minute flush timer before you touch input. Future, you will say thanks. Once your fingers know the drills, the next thing that'll bite you is putting a perfectly good rule in the wrong place. 5 classics. DNAT in filter. Silently ignored because NAT verbs only live in NAT. Filter rule in pre-routing. The chain doesn't exist there. Forgetting -T entirely, which dumps you into filter by default. A drop on output to block incoming SSH, which actually locks you out of SSHing anywhere else. And reject outside filter, which is a flat syntax error. The fix for all 5 is the same muscle. Think matrix first, then type. And that's lesson 3. You now own the full map. 5 tables with filter as home base, 5 chains in packet flow order, the matrix that tells you which combinations are real, and the 4 targets you'll actually reach for. Next up, lesson 4, match conditions. We stop asking where rules live and start asking how to pinpoint exactly which packets they catch. See you there.